Okay, so here we have a tidal wave modeled by this equation that's got a radical in it. So they gave us the equation that is 356 times the square root of d. S is the speed, d is the depth of the water. So part A is asking us to solve this equation for d. So we're doing exactly what we were doing the other days. We want to isolate the square root. So what's in the way? 356. It's attached by multiplication. So the opposite is to divide by 356 on both sides to balance the equation. So I am getting speed over 356 to equal the square root of d. Now that the square root is isolated, we always say squaring both sides. So I'm going to square here, square here. So what happens when I do that? On the right side, I get d. The square for the fraction is going to come inside. So s is going to become s squared. And now use your calculator and figure out what is 356 raised to the second. This is what I got when I put it in the calculator. So this is the equation for A, that I solved it for D. Now part B says a tidal wave is traveling at 150 kilometers per hour. That's the speed. What is the average depth of the water to the nearest thousandths of a kilometer? All right, so let's use the equation, s to the second over that number. And we are going to replace s now with 115. That's squared over that denominator. All right, pause the video, do that in the calculator, and tell me what you get for the depth. Okay, so when I divide, squaring 115 squared divided by that big number, I am getting 0.1043. It keeps going on. It says to the thousands place. So tens, hundreds, thousands. I look at the 4. Next to it's just 3, so I'm not going to round up. I'm going to keep it this answer. So this is the depth of the water.